Okay, here is a basic question of the equilibrium. So question asked is at equilibrium, the concentration of N2, O2 and NO is in a sealed vessel at 800 Kelvin are 3.0 into 10 raised to minus 3 M. Capital M means moles per liter. Always remember this. Capital M means this represents a concentration in molarity, moles per liter. And everywhere it is same, right? 4.2 moles per liter, then 2.8 into 10 raised to minus 3 moles per liter. Calculate the equilibrium constant Kc for this reaction. So equilibrium constant is given as the concentration of the product raised to stoichiometric coefficients, concentration of NO raised to 2 divided by a concentration of N2 divided by concentration of O2, right? There are no stoichiometric coefficients over here. So what are the values of the concentration of NO is given? The concentration of NO is given is this 2.8 into 10 raised to power minus 3. Concentration of N2 is given to be is equal to 3.8 into 10 raised to power minus 3, and the concentration of O2 is given to be 4.2 into 10 raised to power minus 3. Concentration is in capital M means that is as good as writing mole. It is same as writing moles per liter, capital M. If it was small m, then it is molality, moles per kg it is. Okay, just remember this. So therefore, Kc is equal to concentration of NO is 2.8 into 10 raised to power minus 3 in square bracket raised to power 3 divided by 3.8 into 10 raised to minus 3. There is no power over here, and here it is 4.2 into 10 raised to power minus 3. The unit is moles per liter. So further I can write this Kc to be is equal to, I take this, further I can write Kc is equal to 2.8 multiplied by 2.8 into 10 raised to power minus 3 into 10 raised to power minus 3, right? Down I can write 3.8 into 4.2 into 10 raised to power minus 3 into 10 raised to power minus 3. So over here, if you see, then this 10 raised to minus 3, 10 raised to minus 3, these things will get cancelled. Now finally, over here, what you have to deal with these numbers. That is, Kc is equal to 2.8 multiplied by 2.8 and 3.8 into 4.2. So for this, answer will be is equal to, just give me a second. I'll use calculator. You have to use logarithm. You will be not allowed in the examinations with calculator. So 2.8 multiplied by 2.8 divided by, answer is 0.49. And in this case, it is a unitless quantity. If you want to check the units, then it's that simple. I'll show you the calculations for the units also. So units of Kc. Here it is concentration will be in moles per liter raised to 2. Here it is moles per liter into moles per liter, right? So therefore, Kc on the top I'm writing moles per liter into moles per liter since it is square. In this case, here there is no unit for this. So and this will get cancelled. So this is the answer. Okay, I just realized that I have taken a different value from this. This is here it is concentration of N2 is 3 into 10 raised to minus 3. I have taken a 3.8. Let's not change this. I will just change this. Take this to be 3.8. This was the mistake I did. Otherwise, the calculation wise, this is the thing what you need to follow over here. So here is the next question. Again, this is to find the equilibrium constant. The only difference here will be of the unit. Let's see how that units are also different. So equilibrium equation is given as a Kc is equal to concentration of SO3 raised to power 2, because this is the stoichiometric coefficient I am writing. This is concentration of SO2 raised to 2, and this is O2. There is no stoichiometric coefficient, so it is 1. So everywhere the concentration of the the SO2 is given, it is 0.60. Capital M means it is a moles per liter. Then a concentration of O2 is equal to 0.82 moles per liter, and a concentration of SO3 is equal to 1.90 moles per liter. Okay, that is capital M. So Kc will be over here is equal to SO3, right? It is 1.9 raised to 2 divided by concentration of SO2 is given to be 0.6 raised to power 2, and concentration of O2 is 0.82 raised to nothing is there, like raised to 1 is there, since the stoichiometric coefficient is 1. So here this will be is equal to, therefore Kc will be is equal to 1.9 multiplied by 1.9, and this is 0.6 multiplied by 0.6 into 0.8. Okay, let's check the answer, what answer we are getting. I'll use a calculator. 1.9 multiplied by 1.9 divided by 0.6. So answer comes to Kc is equal to 12.53. Here answer given is 12.229. Let's check again. It is 1.9. Yes, 0.82. Yeah, yeah. Here I made a mistake. That is, this is 0.82. Okay. 1.9 multiplied by 1.9 is equal to this divided by 0.6 divided by 0.6 divided by 0.82. Yeah, the answer will come 12.2222. Now, what will be the units over here? Let's check the units also. What will be the units over here? Uh, Units of Kc in this case. Kc, it is moles per liter raised to power 2. Here it is moles per liter raised to 2 for SO2, and here for oxygen there is no power, no, so it is moles per liter. So things what are going to get cancelled is this. What is remaining is Kc is equal to 1 upon moles per liter, right? So therefore Kc is equal to per mole liter, because this will come in the numerator. Here it is 1, it will become 10 raised to sorry, it will become minus 1, and this minus 1 will change to 1. So this is, so per mole liter. So I will write the unit per mole liter. Okay, here is the next question. Determine the Kc for the reaction. This reaction is given, and you need to find the Kc. And the Kp is given. No concentration is given. So relationship between Kp and Kc is this. Kp is equal to Kc into RT raised to delta N. Now, what is delta N over here? We will find. So I will write this. Kc is equal to. I will write Kc is equal to Kp upon RT raised to delta N, and we need to find the Kc for this. So Kp given over here, the given I will write what is given. Kp is equal to 3.4 per bar, that is given. Now temperature is given to be 1000 degrees Celsius. So 1000 degrees Celsius. This to Kelvin it will be 1273 Kelvin, and R, since the pressure is in bar or per bar, then we will take it to be 0.083 liter bar per Kelvin per mole. This will be the unit of R if you are taking this in bar. Okay, then this is R. Now, what is delta N? Delta N is the, since R is a gas constant, N is number of moles of gaseous product minus number of moles of gaseous reactant. Like number of moles of gaseous product is 2 minus gaseous reactant is 2 plus 1. 2 plus 1. Here this is also gas, this is also gas. So this is 1 and this is 2. So 2 plus 1. So this is 2 minus 3, which is equal to minus 1. So delta N is equal to minus 1. That is what we are getting. So Kc will be is equal to, Kp is given to be 3.4. Let's write the units later. Uh, let's solve this numerically. This is 3.4. RT I am taking, R I am taking 0.083 into temperature. It is 1273.15 is there. Let's not take that small value. And delta N is equal to minus 1 over here. So this is whole raised to minus 1. If I take whole term, this whole bracketed term in the numerator, it will become positive. So this will be 3.4 and I am taking whole this term on the top. This I am writing 0.083, 0.083 into 1273 raised to 1. So therefore Kc will be is equal to 3.4 into 0.083 into 1273, right? So over here, answer, let's check the answer. Let's write the answer. 3.4 multiplied by 0.083 multiplied by 1, 2. So answer of the Kc comes to be 359.2. Okay, let's talk about the units also. Let's check this problem if I have done this correctly. So Kp is equal to, this is 3.4 per bar and this is 1273 Kelvin. Then this is 0.083 raised to minus 1. This is fine, right? So Kc I am getting is equal to 3.4 into 0.083 into 1273. So 359.2. Now what will be the units for this? What will be the units for this? So let's talk about the units also here. Right, the units of Kc. This is per bar. Units of R was liter. Okay, let's take the units from here only. Okay, I'll write this way. Liter bar per Kelvin per mole. Liter bar per Kelvin per mole into, this is Kelvin, and here there is raised to minus 1 is there. So therefore Kc will be is equal to per bar. If I open this bracket, then it will be per liter per bar, like bar raised to minus 1. This minus 1 will, and this minus 1 will change to Kelvin, and this will be raised to mole. Minus 1 and minus 1 will change to mole, and this will be Kelvin raised to minus 1. Things what are going to get cancelled is per bar, Kelvin and Kelvin. What remains is unit of Kc is equal to per mole liter. You can write per mole liter. This will be the unit of this. Here is the next question. Equilibrium constant for this reaction is given to be Kc is equal to so and so. This equilibrium constant, this is how the equilibrium constant for one particular reaction is expressed. Write the balance chemical equation for the corresponding expression. So balance chemical equation, the numerator, whatever is written over here is a product, and here it is written as a reactant. So reactants are NO and H2O, and from their powers I can understand what is the stoichiometric coefficient. So for reactants, I am writing the reaction will be 4 since stoichiometric coefficient is 4, like power is 4, that's why stoichiometric coefficient is 4. Here it is 6H2O, and this is reactant, so it is 4NH3 and 5O2. Okay, this will be the reactions for above equilibrium constant expression. Here, next question, which of the following reactions involve homogeneous equilibrium and which involves heterogeneous equilibrium? The case is simple. Homogeneous means all the reactants and the products are in the same phase. Over here, if you see that this is the reactant which is in gas and these are the products which are also in gas. So this is homogeneous equilibrium. Over here, this is gas, this is also gas, and this is also gas. So reactant and product all are in gaseous reactant. So this is homogeneous reactant. This is also homogeneous equilibrium. This will form a homogeneous equilibrium. Over here, if you see, this is solid, and the product what we are getting is gas. This is gas and solid. So we are getting like here reactant and product are in the different phases. So this is heterogeneous equilibrium. Heterogeneous equilibrium. Here, if you see, then this is aqueous liquid, and you are getting a aqueous and the aqueous. So this is liquid, and this is a aqueous form. They are still like it is in the water only, but one is liquid, other aqueous. So this is also I will call a heterogeneous equilibrium. Heterogeneous equilibrium. This is aqueous, and this is solid. Here also the state of the product and the reactant are different, so this is also a heterogeneous equilibrium. Heterogeneous equilibrium. Okay, here next question is based on reaction mixture. This question is like application of the equilibrium. Like this question to understand in which direction a particular reaction will proceed. For example, uh, if QC, basically we talk about the QC reaction quotient. If it is less than QC is less than KC, then it is in the forward direction. The reaction will proceed from the reactant to the product forward direction, right? If QC is greater than KC, then reaction will proceed in a backward direction, that is from left to right. So sorry, right to left, that is in the direction of the reactant. And if QC is equal to KC, that means reaction is at equilibrium, right? Here, let's read the question. A mixture of a hydrogen N2 and NH3 with a molar concentration of so and so, this is the value of the molar concentrations of the nitrogen, hydrogen, and NH3 respectively was prepared and heated to 500 Kelvin. The value of Kc for the reaction, value of Kc for the following reaction at this temperature is 60. Means here the value of equilibrium constant is given. Predict whether the ammonia tend to form or to decompose at this stage of concentration. What they mean is these concentrations, what are what concentrations are over here of hydrogen, nitrogen, and ammonia, these are not at a equilibrium. These concentrations may be at like this concentration may be before equilibrium, before the equilibrium is attained, or it may be addition of or change of the concentrations of the any of the reactant or the product when the after the equilibrium is attained. Okay, it may be after the equilibrium or before the equilibrium. That possibility is there. So these concentrations are not at the equilibrium. That may be anywhere in between before the equilibrium or maybe after the equilibrium. So directly Kc is given. Right, so we will find a QC. QC means it is the concentrations of the product upon reactant, right? At any time, maybe before the equilibrium or after the equilibrium. So let's write it. It looks like same like a equilibrium constant only. For this reaction, the concentration of NH3 is will be is equal to, for this NH3 will be is equal to 2. But these concentrations are not at equilibrium. These concentrations are maybe before or after the equilibrium is attained. So 2, 3, and yeah, this. So what is the concentration of NH3? So QC is equal to concentration of NH3 is 2.0 into 10 raised to minus 3 raised to 2 divided by concentration of H2 is 5 raised to 3, and concentration of N2 is 4.0 into 10 raised to minus 3. There is no powers to this, right? So everything is correct. Hydrogen is 5, nitrogen is 4, and ammonia is 2NH3. So therefore, QC is equal to, this will be 2 multiplied by 2 into 10 raised to minus 3 into 10 raised to minus 3. This is 5 into 5 into 5 into 10 raised to minus 3 into 10 raised to minus 3 into 10 raised to minus 3. And this is 4 into 10 raised to minus 3. Things what are going to get cancelled over here is 10 raised to minus 3 minus 3. This, what is remaining is QC is equal to 4, 25, and into 5 will be 125 into 4. So this will be coming to 125 into 4. Write down it is 500. The powers what are remaining is 10 raised to minus 6. Right. So therefore QC is equal to 4 upon 500, 4 upon 500 into 10 raised to minus 6. I am taking it to be 10 raised to 6 in the numerator. So QC is equal to, so this is 0.08 into 10 raised to 6, which is obviously, if you see, the answer will come to 1, 2, 3, 4, 5, 6. Like this will be answer QC. And here we can see that QC is greater than KC. KC is just given to be 60. QC is greater than KC. That's why the reaction will proceed in a backward direction. Therefore, reaction will proceed in the backward direction. Predict whether the ammonia tend to form or to decompose. So your answer is decomposition of the ammonia, means backward reaction. Decomposition of the ammonia, backward, that is decomposition of NH3 will take place.